VEA works in a very different way to standard aspirating. With a standard VESDA detector, we're using a 25mm pipe with multiple holes in that pipe. And one of the perceived weaknesses of that is there's a lack of addressability. VEA is different in that we're not using a small number of pipes with lots of holes. We're using lots of pipes with only one single hole. So the sampling point here that works at the end of the tube is the only detection point on this tube. The way the detector works is that in its normal state as it is now, the detector's sucking air through all the pipes that are in use. In this case, there's only 6. If it detects an increase in smoke level, it will then start to scan through, and then sequencing through all of the pipes in use on the manifold on the side here, it will identify which pipe or pipes the smoke is generated from. And then the detector will send that signal again to the fire alarm panel, typically through the relay box, which is the unit above. Now, the way this makes the product very unique is that when we start to look at aspirating instead of point detectors for some applications, this becomes a much easier maintenance product. One of the unique features of the way this works is that with the sample point and the tube connected to the detector, the detector sees a pressure through that pipe. And if that pressure changes because the pipe has become broken or somebody has maliciously blocked the sampling point up, the detector will see that. So we don't need to get to the detection point to maintain the system because the detector is proving that the sampling point is still sound. So this then lends itself to areas where point detectors would be a good solution, but perhaps because of maintenance or aesthetics, they become too difficult to use. So hospitals, for example, student accommodation or custody suites are a good application of where this product would become beneficial.